Straight streets run across a green hillside in Pennsylvania. Sidewalks end at nothing. Iron hydrants stand in waist-high grass where houses used to be. From above, the town is still drawn on the ground. Centralia, Pennsylvania, once held about 1,200 people. Today, the census counts 5. So, here is the question this hillside asks. What moved in after almost everyone moved out? In May 1962, crews set light to a trash pile in an old strip pit at the edge of town. Underneath ran a coal seam, a buried layer of fuel threading through these hills. Burning garbage in that pit was routine. This time, the heat slipped into the Buck Mountain coal bed and the tunnels around it. Nobody could reach it. Water, drilling, and trenches all failed. By 1979, the mayor lowered a thermometer into a fuel tank at his gas station. It read 172 degrees Fahrenheit. Then, on Valentine's Day 1981, the ground opened under a 12-year-old boy. His cousin pulled him out. Not long after, Congress funded a voluntary buyout. Over the next decade, the state acquired 545 homes and businesses. Families packed up and left. Crews took the buildings down, one street at a time. By 1990-63, people were still living on the hill. In 1992, the governor condemned every remaining building. 10 years later, the zip code itself was withdrawn. The state kept watching the ground it had emptied. Crews drilled boreholes to track the heat and studied the gases seeping out of the hill. None of it slowed the fire. What happens to a hillside when the mowing stops? Nobody planned an answer. Pennsylvania simply forbade new houses here, and then went quiet about the rest. That ban did the work of 100 restoration grants. No one mowed a lawn or resealed a driveway. Nothing was bought here, and nothing planted. Leaving land alone looks like neglect. On the ground, it means seed heads standing all winter. Leaf litter piles up on the sidewalks and stays there. No permit was needed for any of it. Coal underground does not burn like a campfire. It smolders, feeding on air that leaks in through cracks and old shafts. Take away the air and it stalls. Meanwhile, the burn kept moving. Researchers put its advance at 3 to 7 meters a year along the seams. It travels where the fuel is, and it takes the oxygen it finds in old workings. That slow crawl matters more than it sounds. Ground that scorched in the 1970s has since gone cold. The heat leaves, and the earth behind it is left empty and open. So Centralia is not one place. It is a moving band of temperatures laid across one hill, from ordinary green woodland to bare, steaming clay. For scientists, that is unusual and useful. One hillside holds the whole range at once, still hot, cooling, cold again, and never touched, and that is where the surprise turns up. Walk the empty grid on a wet morning and you find the vents. Small holes in the slope, breathing white steam where rain has reached the heat below. Right beside them, the dirt has been cooked. Surface temperatures at the worst spots have been measured near 400 degrees Celsius. More recently, hot sites sit closer to 60. 60 degrees still cooks a root. So for years, the question stayed simple. Does anything live in ground that warm? And does anything come back afterward? A team from Michigan State University has returned to this hillside for 7 straight years. Ashley Shade and her colleagues sample the same points each time. Scorched soil, cooling soil, and untouched woodland nearby. The work is unglamorous. A gloved hand pushes a steel tube into pale, cracked clay. The core comes up warm, then rides home on ice. Repeat that season after season, and you get a record. Not a snapshot. They are not counting trees. What they count is bacteria, the single-celled life that turns dead leaves back into dirt. In the worst samples, that census collapses. Why care about something you cannot see? Because a hillside cannot rebuild itself without them. Bacteria release the nutrients that roots pull up, and green things depend on that. Diversity drops hard. Whatever hangs on tends to be small. Tiny cells, carrying stripped-down instruction sets, built for a life with almost no comfort in it. Stranger still, the hot samples disagree with each other. Two scorched patches, a short walk apart, hold different communities. Extreme heat does not produce one predictable survivor list. Then came the finding that changed the mood of the project. The team looked at plots where the burn had passed by, and the earth had cooled again. Those recovered plots did not stay strange. Their bacterial communities converged, drifting back toward the makeup of the untouched woodland alongside them. Close to a full return. So the same fire does two opposite things. It drives each patch somewhere different. Then, as the ground cools, it brings them all to one place. The timescale is the part worth holding on to. 10 to 20 years after the heat left, the buried world looked much like it did before. The ground below rebuilt itself. In 2024, the team published 7 years of that data for anyone to use. Other labs can now test the same hillside without ever visiting it. Later work added a caution. Some of that apparent return comes from cells that arrive and simply wait, present but inactive. Recovery on paper is not always recovery at work. Above ground, the comeback is easier to see and harder to date. Nobody photographed the first switchgrass. There was no ribbon cutting for the first white oak. Walk the streets now, and the plant list reads like a young meadow, turning into woods. Broom sedge and switchgrass. Big bluestem, the grass old farmers called turkeyfoot. By late summer, the stems rise chest-high over the sidewalks. In autumn, the whole slope turns copper and rust. From a distance, the old lots read as one continuous field. Then the shrubs, silky dogwood pushing up through the grass. Then the trees. Young white oaks and lindens are already standing above the seed heads. That sequence has a name in ecology: succession, the orderly handover from meadow to shrub to forest. Centralia is running it in the open, on an old street grid. None of it was planted. The asphalt is still there, so the green stops at the curb line and starts again on the far side. So how did any of it get here? Seeds ride in on the wind and in bird droppings, then land in a crack in the pavement. A crack is all a root needs. One piece was deliberate, though. In 2021, a local mine reclamation group set 250 apple trees into this ground, hoping to pull in butterflies. The group behind that planting works on abandoned mine land across eastern Pennsylvania. Their usual job is repairing what the coal industry left behind. Here they were adding to something already recovering on its own. Their aim is a monarch way station, a certified stop for migrating monarch butterflies. Apple blossom in May, and a place to break the journey north. Those insects are a fair test of a place like this. They need flowers in sun, shelter from wind, and bare warm ground to sit on. It is a small human gesture beside something much larger. 250 saplings next to the 400 surface acres this underground burn has touched. Habitat structure matters more than any single species list. Tall grass hides low nests. Shrubs give songbirds nesting sites, and young oaks feed the insects that feed everything else. And here is the honest gap. The soil below has been sampled for 7 years running. The plants and animals above it have had nothing like that attention. So the greenest part of this comeback is also the least documented. Visitors describe a riot of green. Science can only vouch for what happens under their boots. Set two censuses beside each other. In 1962, about 1,200 people lived in Centralia. In 2020, the count was 5. 5 residents on 155 acres of borough. The emptying took time. The 1980 census still counted 1,017 residents here. Most of them held out while the buyout ran. The houses came down through the decade that followed. That is the human arithmetic. The ecological arithmetic runs the other way, and it is the more surprising of the two. We left, and other lives arrived. Look at the ground first, because that is where the record is strongest. Cooled plots that once ran near 400 degrees now hold soil life close to the woodland next door, 10 to 20 years. That is what it took, in a place people wrote off as ruined forever. The recovery clock here ran far shorter than the reputation did. Stand at the edge of a bare patch and the line is sharp. Cooked clay on one side, thick growth on the other. As the heat moves on, that edge shifts with it. Then look up. Graffiti Highway was a closed stretch of Route 61, painted end to end by visitors. In 2020, the landowner buried it under dirt. Tourists mourned it. Ecologically, the burial did something else. It handed a long strip of dead asphalt back to the succession running all around it. The last tourist draw is gone, and the hill is quieter than it has been in 40 years. Fewer visitors means fewer bonfires and less trampling, which leaves a strange result. Pennsylvania has, without ever writing the words, created a 400-acre preserve by forbidding everything except growth. It has no staff and no gate. 6 decades of burning is hard to picture. It started before the first moon landing, and it has not stopped since. The people who lit that trash pile are gone now. The burn is still down there, working through the seams. Estimates for how long it can keep going run from decades to centuries, and nobody can narrow that honestly. On a rainy afternoon, the vents give off thin white steam. It looks almost gentle. The heat is still crossing the hill beneath your boots. Behind it, cooled ground is quietly rebuilding what the heat took. Grass is closing over the street where a post office stood. Both things are true at once. Centralia never became the town it was. It became something nobody applied for. If you'd like more evidence-led stories of recovery, subscribe to TerraEcho. We'll meet you in the next landscape.